Hello guys, a warm welcome to the next session of data science with Python programming. How are you guys? I hope everyone is fine and everyone is learning data science with Python programming from my first session to till now. Yeah. So by the way, I hope you remember in a previous session we have seen regression analysis, right? So under the regression analysis, we have seen simple linear regression, multiple linear regression, and polynomial regression. Yeah, and we have also implemented simple linear regression, multiple linear regression, and polynomial regression. Am I right? Yeah. So for a simple linear regression, what we have done? We have implemented a problem. We have found the solution of the problem that based on the height of the person, what will be the weight of the person, right? For a multiple linear regression, what we have done? Based on the weight of the car, based on the volume of the car, what will be the CO2 emission of the car? Am I right? So I hope you remember all those things. Yeah. And I hope how can you apply the regression in the real world problem? Okay. How can you solve the real world problem with the help of regression? Yeah. And by the way, I hope you also remember supervised learnings are classified into two categories of algorithm: regression and classification. So under the regression, we have seen simple linear regression, multiple linear regression, and polynomial regression with the theory part with the implementation of each of these algorithms, right? So now let's start with the next point, that is classification. Okay, as you know that supervised learnings are classified into two categories of algorithms: regression and classification. So we have seen regression in a previous session. Now it's time for us to learn, okay, about the classification and to learn what are the algorithms for classification. Okay, so let me show you what you are exactly going to learn in this session. So see, first of all, you will understand what is classification, and then you will learn classification algorithms. What are the classification algorithms are there? So the first algorithm you will study under the classification is logistic regression. Okay, so you might think, is it a regression? No, it's not a regression. Logistic regression is one of the algorithm under the classification. Okay, and then you will learn implementing logistic regression. Okay, after that you will learn decision tree. It is also one of the algorithm under the classification. Once you know the theory about decision tree, you will learn implementation of decision tree classification. Yeah. So you have decision tree classification, yeah, in data science methodology a lot, yeah. So in this session, you will come to know what is decision tree and how can you implement, how can you solve a real world problem with the help of decision tree. Okay, so you will learn the theory about it and you will learn the implementation of decision tree classification. Okay, after that, you will learn support vector machine. That is also one of the algorithm under the classification. Once you learn the theory about it, you will learn then implementation of support vector machine. Okay, so let's start with the first point. What is classification? So by the way, I hope you remember the basic thing about the classification. Tell me. Okay, let me show you what is classification. So see, classification is a process of categorizing a given set of data into the classes. It can be performed on both the structured or unstructured data. The process starts with predicting the class of given data point. The classes are often referred to as target, label, or categories. The classification predictive modeling is the task of approximating the mapping function from input variable to discrete output variable. The main goal is to identify which class or category the new data will fall into. Okay. So classification is a process of categorizing the given set of data into the classes. It can be performed on both the structured or unstructured data. The process starts with predicting the class of given data point. The classes are often referred to as the target, label, or categories. Okay. The main goal of classification is to identify which class or the category the new data will fall into. Okay. An easy to understand example of classification is classifying an email as spam or not spam. Okay. So I hope you know the Gmail. In the Gmail, you receive the emails on your inbox, or sometimes you receive your emails on the spam. So classifying your email as spam or not spam is one of the example of classification. Okay. Let us try to understand the classification with the help of some other example. Okay. Let's see. Hard decision detection can be identified as a classification problem. This is binary classification since there can be only two classes. That is, has heart disease or doesn't have the heart disease. Okay. So heart disease detection. Heart disease detection can be identified as a classification problem. This is the binary classification since there are only two classes. First one is whether a person has the heart disease or he doesn't have the heart disease. Okay. The classifier in this case needs training data to understand how the given input variables are related to the class. And once the classifier is trained accurately, it can be used to detect whether the heart disease is there or not for a particular patient. Got it? So heart disease detection can be identified as a classification problem, and it is a binary classification since there are only two classes. That is whether a patient has the heart disease or doesn't have the heart disease. Okay, got it? Classification is again divided into three other categories or problems, which are binary classification, multi-class or multinomial classification, and multi-label classification. Okay. So classification is again divided into three other categories. First one is binary classification, next one is multi-class classification, and the third one is multi-label classification. So binary classification is nothing but predicting whether an email is a spam or not are a binary classification problem. So the example of binary classification is predicting whether an email is a spam or not are the example of binary classification problem. Okay. Even we have seen one. We have just seen the example whether a patient have heart disease or not. This is also the example of binary classification. Okay. Now, what is multi-class or multinomial classification? So see, identifying the news, classifying the news into the different categories such as sports, entertainment, political are the example of multi-class or multinomial classification. Okay. So classifying the news into different categories such as sports, entertainment, political, or you can say it classifying the news into different categories of sports news, entertainment news, or political news are the example of multi-class classification. Now multi-label classification. Multi-label classification is a predictive modeling task that involves predicting zero or more mutually non-exclusive class labels. Got it? Yeah. So classifications are again divided into three categories: binary classification, multi-class or multinomial classification, multi-label classification. So binary classification is, yeah, the example of binary classification can be classifying the email into spam or not spam is the example of binary classification. Whether a patient will have the disease or whether the patient will have the heart disease or not is again the example of binary classification. What is the example of multi-class or multinomial classification? Classifying the news into different categories such as sports news, entertainment news, political news are the example of multi-class classification. And multi-label classification. Multi-label classification is a predictive modeling task that involves predicting the zero or more mutually non-exclusive class labels. Okay. There is, so got it. So I hope now you understand what is a classification. So in simple term, you can say that classification is a process of categorizing a given set of data into the different categories or different classes or the labels. Okay. Now let us see classification algorithms. Okay. There is a lot of classification algorithms available now, but it is not possible to conclude which one is superior to other one. It depends on the application and the nature of available dataset. So some of the important classification algorithms are, first one is logistic regression, and then the decision tree, and then the support vector machine, and then k nearest neighbors, Naive Bayes classifier, random forest. Okay. So these are some important classification algorithm. Okay. Even though there is lot of classification algorithms are available, but it is not possible to conclude which one is superior to other one, because it depends on the application and the nature of available data sets. So some of the important classification algorithms are logistic regression, decision tree, support vector machine, k nearest neighbor, Naive Bayes classifier, random forest. Okay. So here we will understand some important classification algorithm. So in this session, you are going to learn logistic regression, decision tree, and support vector machine. Okay. So let's start. Let us look at the first classification algorithm. Okay, in machine learning, in supervised machine learning, under the classification, that is logistic regression. So logistic regression is very important algorithm under the classification. Okay. So let's see what is logistic regression. So see, logistic regression is analogous to the linear regression, but tries to predict a categorical or discrete target field instead of numeric one. Okay. So logistic regression is analogous to the linear regression, but it tries to predict the categorical or discrete target field instead of numeric one. Since in the linear regression, multiple linear regression, okay, in polynomial regression, we try to predict the values which is in terms of number. But in case of logistic regression, it is going to predict a categorical value or a discrete target field instead of numeric one. Logistic regression is a classification and not a regression algorithm. Please make a note of it. You might think the term regression is there. So does it come under the regression? No. So make a note of it. Logistic regression is a classification and not a regression algorithm. It estimates discrete values, the binary values like 0 or 1, yes or no, true or false, based on the given set of independent variables. Simply put, it basically predicts the probability of occurrence of an event by fitting the data to the logit function. Hence, it is known as logit regression. The values obtained would always lie within 0 and 1 since it predicts the probability. Okay, are you getting the point? So, whether the rain is going to come today or not, yes or no. Okay, whether you are going to pass the exam, yes or no. Okay, based on your PS record. Okay, whether a patient have a disease, heart disease, yes or no. So all these type of problem you can solve using the logistic regression, because logistic regression is tries to predict a categorical or discrete target field instead of numeric one. Okay, yeah. So logistic regression is a classification and it is not a regression algorithm. It estimates the discrete values such as the binary values like 0 or 1, yes or no, true or false, based on a given set of independent variables. Okay. Simply put, it basically predicts the probability of occurrence of an event by fitting the data to the logit function. Hence, it is also known as logit regression. The values obtained would always lie within 0 and 1 since it predicts the probability. Okay. We use the logistic regression for a binary classification of data points. So what is a binary classification? Yeah, the example of binary classification is classifying your email into the whether your email is spam, not spam, whether a patient will have the heart disease or not. Yeah. So these are the example of classification. Yeah, sorry, binary classification. Okay. So we use the logistic regression for a binary classification of data points. We perform the categorical classification such that an output belongs to either of the two classes, 1 or 0. Okay. For example, we can predict whether it will rain today or not based on a current weather conditions. The goal of logistic regression is to find a best fitting relationship between the dependent variable and a set of independent variables. It is better than other binary classification algorithms like nearest neighbor since it quantitatively explains the factors leading to the classification. Got the point? Yeah. So logistic regression is useful for a binary classification of data points. Okay. So we perform the categorical classification such that an output belongs to either of the two class, 1 or 0. Got the point? So for example, if you want to predict whether it will rain today or not based on the current weather situation, that is a example of binary classification. So we are going to use the logistic regression for binary classification of data. And the output here, yeah, it is going to belongs to either of the two class, 1 or 0. Got the point? The goal of logistic regression is to find a best fitting relationship between the dependent variable and a set of independent variables. It is better than other binary classification algorithms like nearest neighbor since it quantitatively explains the factor leading to the classification. Okay, got the point? Now it's time for us to start implementing logistic regression. Okay, so let's see the implementation of logistic regression. So by the way, I hope you got a clear concept of logistic regression. So logistic regression is analogous to simple linear regression, but it is going to predict the outcome in terms of discrete values or in terms of values that belong to the two classes, either 1 or 0. Yeah. Logistic regression is analogous to the linear regression, but it tries to predict the categorical or a discrete target field instead of numeric one. Okay. And logistic regression is a classification. It is not a regression algorithm. Logistic regression estimates the discrete values based on a given set of independent variables. Okay. Now let's see implementation of logistic regression. Okay. Let's now see how to apply the logistic regression in Python using a practical example. Okay, so what is our goal here? So see the question here. Our goal is to build a logistic regression model in Python in order to determine whether the candidates would get admitted to a prestigious university based on a GMAT score, GPA, and work experience. Got the point? Yes. What we want to do here? We are going to solve this problem whether the student will get the admission into the prestigious university based on his score on GMAT, based on the GPA, and based on his work experience. Are you getting the point? So you got the question. And what will be the outcome? The outcome should be either he will get the admission or he will get rejected. Okay. Either he will get the admission or not. Okay, so our goal is to build a logistic regression model in Python in order to determine whether the candidates would get admitted to the university, would get admitted to the prestigious university based on the GMAT score, based on the GPA and the work experience of the candidates. Got the question? Yes. So the outcome of logistic regression will be 1 or 0. For example, whether he will get the admission. If he's getting the admission, so you can say yes, or you can say represent it as a 1. And if he doesn't get the admission based on the GMAT, GPA and work experience, then you can represent it with the help of 0 or no, whatever it is. So it's important for us before going to start building the logistic regression, it is important for us to understand the problem. So what is our problem? Here, our goal is to build a logistic regression model in order to determine whether the candidates will get admitted to the prestigious university based on the GMAT score, GPA, and work experience. Got the point? Yes. So now let's start it. So I hope you clear with the question, our goal. Yeah. So see, let's start with the step 1. Import the needed package of Python. So before you start, make sure that following Python packages are installed in Python. So we have already seen that we have already installed the pandas, sklearn and matplotlib. So pandas, which is used to create the data frame to capture the dataset in Python, sklearn, scikit-learn, which is used to build the logistic regression model in Python. So sklearn, static learn, scikit-learn, sorry, sklearn or scikit-learn. It is very, very important data science library, which is going to help us a lot for building various type of models in machine learning. So sklearn here, since we are learning logistic regression, so we are going to make a use of scikit-learn, sklearn to build a logistic regression model in Python. And then matplotlib, I hope you know that, yeah, which is useful for a data visualization in order to display the chart. Okay, so import the needed packages. Okay, so see, you will then need to import all the packages as follows. So import pandas SPD, and then from sklearn dot model underscore selection import train test split. Okay, why we are using it? So that we can divide our data into the training set and testing set. Okay, and then from sklearn dot linear underscore model import logistic regression. Since we are implementing the logistic regression, so it is important to import it from sklearn dot linear underscore model import logistic regression. And finally, import matplotlib dot pyplot splt. Okay, so here from sklearn dot model underscore selection import train underscore test underscore split is useful to split the arrays or the matrices into the random train and test subset. Okay, got the point? After implementing the necessary Python packages, what is the next step? Next step to gather your data. So let's look at the data sets. So here there are two possible outcomes. Admitted, whether the student will get the admission into the university, which is represented by the value of 1, versus rejected, which is represented by the value of 0. Okay, now let me show you the data set that you are going to use, that we are going to implement, that we are going to use for implementing the logistic regression. So see here, this is the data set that I'm going to use. Okay, so can you see this one? So based on the GMAT score, based on the GPA, based on the work experience, this is the admission, admitted. 1 is represented that the student would get admitted into the prestigious university, and 0 means he got rejected, he doesn't got the admission into the prestigious university. Okay, so if the student got 780 marks in GMAT, if he has a GPA of score 4 and he has 3 years of work experience, then he would get admitted in the prestigious university. He got the admission. In the same way, if the student got 750 marks in GMAT with 3.9 GPA with 4 years of experience, he also got admitted in a he also got the admission in a prestigious university. But if the student got 690 marks in GMAT and if he has 3.3 GPA with 3 years of experience, but so that student got rejected. He doesn't got the admission into the prestigious university. So based on this data set, we are going to build the logistic regression model that is going to predict whether the candidate would get admission or would get admitted to the prestigious university based on his score in GMAT, based on the GPA, and based on work experience. So this is our data set that I am going to use. So see here, there are two possible outcomes: admitted, rejected. So admitted means it is represented by the value of 1, rejected represented by the value of 0. Can you see this one? This is our outcome. This is our dependent variable. Okay, so 1 0 1 0. So 1 means the student got the admission, 0 means the student get rejected. Okay, so now by looking at the data, we come to know that there are two possible outcomes: admitted, rejected. So admitted is represented by the value 1 and rejected represented by the value 0. Okay, now you can build a logistic regression in Python where 3 independent variables are the GMAT score, GPA, and years of work experience. Okay, so these are our 3 independent values. Based on these 3, we are going to predict whether the student get the admission or not. Okay, so these are our three independent variables or the values that we are going to put in x-axis for we are going to assign it for a x. Okay, the dependent variable represent whether a person get admitted or not, whether a candidate get admitted or not, whether the candidate will get the admission or not. That is our y. Okay, that is this one, admitted. Okay, so these are our independent values. Okay, these are the independent variables that we are going to assign to the x, and this is our dependent or the dependent variable or the response variable. Okay, now after that, what is going to we need to do? So we have let's look at the data set. We are already looking at the data set. So the next step, obviously, we need to read the data from the data set from this CSV file. How to read a data from the CSV file? Obviously, we need to read a data from the CSV file with the help of pandas. So bt.read_csv, inside a parenthesis, inside a single quote, you need to specify the path where this file is present. Okay. So let's perform the initial two steps. So see here, I have already opened the Jupyter notebook. First of all, import the necessary Python packages. Let me run this code in front of you. So see, it's 7. If I run it again, it will become 8. How to run it? By pressing Shift Enter. Okay. Import pandas SPD so that using this one we can read a data from the CSV file. And then from sklearn.model selection, import train_test_split. With the help of this one, we are going to split our data into training set and testing set. And then from sklearn.linear model, linear_model, import logistic regression so that we can build a logistic regression model. And then import matplotlib.pyplot splt so that if you want to do the data visualization, you can do it. After importing the necessary packages, the next step is to look at the dataset. So we have looking at the dataset. So the next step is to read this CSV file. So how to read it? pd.read_csv, inside the parentheses, specify the path where this file is present. So this file is present under the local disk F, under the folder Arizona Studio. Under that, I have the file admission.csv. Let me show you that. So see, under this one, f:/Arizona Studio. Under this one, I have the file admission.csv. Can you see this one? Yeah. So you just copy it and paste it here. And the result of this one, you can assign to the data frame object df. Let me run this code in front of you. So see here. Now df is going to hold all the data set, all these values. So how many rows we have? 40 rows. Okay, 40 records. Yeah. So yeah. So what is the next step? We have read the data. Now, if you want to look at the initial 10 records of your data set, then you can make a use of head function, head method, df.head 10. So let me run this code. So you are going to get the initial 10 records, initial 10 rows of your data set. So see here, GMAT, GPA, work experience admitted. Is it correct? GMAT, GPA, work experience admitted. 780, 750, 690, 710. 780, 750, 690, 710 till this one, 690. Okay. If you want to look at the last 10 rows of your data set, then you can make a use of tell method. So df.tell 10. So here 10 indicate last 10 rows. Let me run this code. So can you see this one? These are the last 10 rows. So see here 690, 590, 580. Let me show you that. 690, 590, 580. Yeah, is it correct? Okay, so last 10 rows. Now, what is the next step? Once you have imported the necessary packages, once you read a data from the CSV file, then the third step is to divide the given columns into the two types of variable. Dependent variable or a target variable or a response variable. Okay, dependent variable is also called target variable or a response variable. And independent variable or a feature variable. Okay. So from our data set, what we need to do? We need to divide the given columns into the two types of variable, dependent variable and independent variable. So what is our goal? Our goal is to build a logistic regression model that will predict whether the candidate would get admitted to the prestigious university based on a GMAT score, based on the GPA, and based on the work experience. So here we need to categorize, we need to divide the columns of GMAT, GPA, and work experience to the dependent variable. Okay, so based on the GMAT, based on the GPA and work experience, we need to predict whether the student get admission or not. So we need to consider the column GMAT, GPA, and work experience as a independent variable. Yeah, as a independent variable. Okay, and what is my dependent variable? What is my dependent variable? Okay, dependent variable is my admitted, or dependent variable is also known as target variable or response variable, and independent variable is also known as feature variable. Okay, so based on the GMAT, GPA, and work experience, I need to predict whether the student get admission or not. So based on these three, I need to predict whether the student get admission or not. So I need to consider the column of GMAT, GPA, and work experience as a independent variable. So I need to divide the given columns into the two types of variables, dependent and independent variable. So I will, how can I access the record of GMAT, GPA, and work experience from my data frame, data set? So how to access it? Df of square bracket. Inside a list, you need to specify the name of the column, GMAT, comma, GPA, comma, work experience. And these three, okay, you are going to assign to the X. Okay, so here the independent variables represented as X and the dependent variable represented as Y. So here X is nothing but it is going to hold all the record under all the records of a GMAT score, GPA, work experience. Okay. And Y is our dependent variable because based on the GMAT, GPA, work experience, we need to predict whether the student will get admission or not. So GMAT, GPA, and work experience is our independent variable. So I will access GMAT, GPA, and work experience columns, and I will assign it to the independent variable X. Okay. And admitted, since our logistic regression is going to predict whether he will get admission or not. So I will access the fourth column, admitted, df of square bracket admitted, and will assign it to the Y. So X is my independent variable, Y is my dependent variable. Got it? So let me access, let me run this code. So see here, let me run this code in front of you. So it's 12. Yes. After that, if you want to see what is the how the value of X look like, let me run this code now in front of you. Okay, it's capital X. See here. These are my independent. X is my independent variable that contain all the record of GMAT, GPA, and work experience. Can you see this one? Okay. So first step, import the necessary Python package. Next step is to read a data from the CSV file and then divide the columns into the independent and dependent variables. So we have considered these three factors because for admission, the student need to have a good GMAT score, good GPA, and good work experience. So based on a GMAT, GPA, and work experience, we need to predict whether he will get admission or not. So we need to access all these three columns, GMAT, GPA, and work experience. That is our independent variables. Okay. I need to access these three columns and set it to the X. That is my independent variable. So how can I access GMAT, GPA, and work experience? So it's very easy. Write the name of your data frame inside a square bracket, inside a single list, supply the name of the column. So GMAT, GPA, and work experience. The result of this one I'm assigning to the X. So X is my independent variables. And this independent variable is contain all the record of the column GMAT, GPA, and work experience. Because based on this GMAT, GPA, and work experience, we will predict whether the student will get the admission or not. Okay. And Y is our dependent variable. Okay. Y is our dependent variable. Dependent variable is also known as feature variable. Sorry, the response variable or target variable. Independent variable is also known as feature variable. Even it is called predictor variable. Independent variable is also called predictor variable or feature variable. So don't get confused with this one. Okay. Just understand, just make independent variable, dependent variable. Independent variable is nothing but we are going to use these values, okay, for predicting the value of dependent variable. Okay. So based on a GMAT, GPA and work experience, so we have accessed GMAT, GPA and work experience column of our data frame, and we have assigned to the X. So X is our independent variables, because we are going to use the data of independent variable, the values of independent variable, to predict the value of dependent variable. So Y is our dependent variable. So dependent variable is also known as target variable or a response variable, whereas independent variable is also known as feature variable. Okay, don't get confused. Okay, so now X is my independent variable, Y is my dependent variable. X contain all the records of GMAT, GPA work experience, and Y is going to contain all the records of admitted, the fourth column, if you want to see this one. Okay, now let's see the fourth step. We have seen the three steps. Now let's see the fourth step. Fourth step is to split the data, splitting data. To understand the model performance, dividing the data set into the training set and a test set is a good strategy. So let's split the data set by using the function train underscore test underscore split. So here you need to pass the three parameters, at least three parameters into this function. First one is independent variable, second one is a dependent variable, and the third one is test underscore size. Test underscore set this parameter. Okay, that is going to set the size, and additionally you can also pass the fourth parameter random underscore state to select the records randomly. So see here, how can you write it? So this function is going to return four values: x underscore train, training set for x, x underscore test, testing set of x, y underscore train, the training set for y, comma y underscore test, testing set of this y, is equal to train underscore test underscore split. So first one is you need to pass the independent variable, second one is dependent variable, and then test underscore size. Yeah, test underscore size is equal to 0.25, comma random underscore state is equal to 0. Okay. Yeah, so here you need to write test underscore size, not the, yeah, test underscore size. That is going to set the size. Okay. So here the dataset is broken down into two parts in a ratio of 75:25. This means 75% of data will be used for model training and 25% of the model is used for 25% of the data is used for model testing. Why 25%? Because you have said test underscore size is equal to 0.25. This means 25% of data you are going to use for model testing, whereas 75% of the data you are going to use for training the model. Got it? Yeah, test underscore size. This parameter is going to specify 0.25. This means you want to use 25% of data for testing the model, whereas remaining 75% of data you are going to use for training the model. Comma random underscore state is equal to 0, so that you will, every time you run the code, you will get the same data for training set, for testing set. Okay. So now let's run this code. Let's perform the step 4. So 3 x underscore train comma y and x underscore test comma y underscore train comma y underscore test is equal to train underscore test underscore split. So pass independent variable, dependent variable, test underscore size is equal to 0.25. This means you're going to use 25% of data for testing the model, and remaining 75% you're going to use for training the model, and then comma random underscore state is equal to 0, so that every time you should get the same data. Let me run this code in front of you. So see, it's become 16. Okay, just a minute, let me run this code in front of you. So it becomes 17 now, it should become 18 now. Yeah, can you see this one? So we have now training set of x, testing set of x, training set for y, testing set for y. So totally how much record we have? See, we have total 40 records. So what is the 25% of 40? 10. So this means there will be a total 10 records for x underscore test, y underscore test. If you want to check it, y underscore test, let me run this code in front of you. Can you see this one? Y underscore test 0, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 records are there. Even if you want to check x underscore test, so x, what is my x? X is my independent variable. So independent variable is going to have 3 columns data: GMAT, GPA, and work experience. Let me run this code. So it should also contain 10 records. Let me run this code in front of you. See here, GMAT, GPA, work experience. So if you want to count it, how much records you have, how many rows you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Whereas the x underscore train, y underscore train, these, okay, this one is going to contain 30 records. If you want to check it, you can check it. This is our training data, total 30 rows. Even if you want to check y underscore train, yeah, see here, total 30 records. Got it? And y underscore test is, yeah. So see, we are going to use training data for, so that we can train the model. And then once the model is trained, then we are going to check it. We are going to test the model with testing data. So see, for example, what is the purpose of this one? As per the theory, to understand the model performance, dividing the data set into training set and test set is good strategy. Okay. So see, here the data set is broken down into the two parts in a ratio of 75 to 25. So 75% of the data will be used for model training and 25% of the data is going to use for model testing. Okay, so we have broken down, we have performed the step for now. Okay, so this is our training x underscore train, that is our training data for x, y underscore train, training data for y, and x underscore test, y underscore test. Okay, so y underscore test, this is our, yeah, testing, y underscore test. Okay, the data of y for which is useful for testing. We will see that how can you check it, but as of now we have splitted the data into two portions. We have broken down the data into the two parts. 25% of data is useful for testing the model and 75% of data will be used for training the model. So we have used total 30 records for training the model. After that, what is the next step? The step 5, that is model development and prediction. So see here. First, import the logistic regression module and create a logistic regression classifier object using logistic regression function. And then fit your model on the training set using the fit method and perform the prediction on the test set using the predict method. Okay, so we are going to perform the prediction on a test set using the predict. So first of all, import the logistic regression module. So we have already imported it. So we need to create the logistic regression classifier object using logistic regression function. So see, logistic regression function we have used, and here comes the logistic regression classifier object. Okay, so then fit your model on the training set. So this is my model, logistic regression classifier object, or my model dot fit, and then I need to, what we need to do, we need to fit the model on the training set. So x underscore train comma y underscore train. So independent variable comma dependent variable. Okay. So once you're done with the, once you fit your model on the training set using the fit method, and then finally you have the model which is ready to predict the values. So perform the prediction on the test set. Perform the prediction on the test set using the predict method. So what is my model? Regression classifier object, this one. So logistic underscore regression dot predict. And I need to use at this time which data? Testing data, x underscore test, and the result of this one you can assign to the y underscore predict. So let's perform this step 5. So see here, creating the logistic regression classifier object. Okay, let me run this code in front of you. So this is my logistic regression classifier object. Once you have, you need to fit the model on the training data. So logistic regression underscore regression dot fit x underscore train comma y underscore train. Fit the model with the data. Let me run this code in front of you. So see, it's running, so it become 25. So now you have the model ready for prediction. And then use the model for predicting. Okay, perform the prediction on test data. Perform the prediction on test set using the predict method. So see, this is my logistic regression classifier object. So I will use it dot predict, and then I will use the test data. So what is the test data? X underscore test. The result of this one I can assign to y underscore predict. So let me run this code. So can you see that it's run? Now let's see the predicted values of y. Let me run this code in front of you. See, can you see this one? This is the predicted values for x underscore test. So what is x underscore test? If you want to check it again here, so see, if you want to check x underscore test, so see, for these values, if the GMAT score is 550, if the GPA 2.3, if the work experience 4, the predicted outcome is 0. This means the student doesn't got the admission. Yes. And if the GMAT score is 670 with the GPA of 3.3 with the 6 years of experience, this student, the third one, would get the admission as per the predicted values. Got it? So 10 records we have here. So for these 10 records, we have this output, predicted values of y. Okay. But you have the actual value of the y. See here, y underscore test. Y underscore test. This is the actual values. So see, the outcomes is coming here 0, 1, 1, 0, 0, 0, 1, 1, 0, 1. So how many values has been predicted correctly? So see, it's 0, 0, 1, 1. So but it is 0, 1, 1. Here it's coming predicting 0, but here it's predicting 1, but the actual value is 0. And then 0, 0, 1, 1, 0, 1. So out of 10, 2 predicted outcomes are incorrect, whereas the remaining 8 outcomes are remaining 8 predicted values are correct. Yeah, this is the predicted values, whereas y underscore test, this is our actual value. Yes. So we have used the predict method on testing set of x, and then that will become y predicted values of y. So this is the predicted values of y, and y underscore test is nothing but our actual values. Yeah. So see here, the actual value is 0. For here is 0. It is 0. It is 1. So here comes the first one is wrong. Yeah, this one is wrong. And then 1, 1. So see, 1, 1. So this is also wrong. Here it is predicting 1, but the actual value is 0. Whereas all the others are, is it correct? Yes, here 0, 0, 1, 1, 0, 1. 0, 0, 1, 1, 0, 1. Got it? Okay, now let's see. So we have developed the model. We also have done the prediction of it. Now it's important for us to do the model evaluation. So that is our sixth step. So model evaluation you can do in case of logistic regression using the confusion matrix. So see, a confusion matrix is a table that is used to evaluate the performance of classification model. You can also visualize the performance of an algorithm. The fundamental of confusion matrix is the number of correct and incorrect prediction are summed up class-wise. So by the way, by looking at this data also, this is the actual values, okay, and these are the predicted values. By looking at this data, you will also come to know that out of 10, our model has predicted 8 correct values and 2 incorrect values. So the accuracy of the model is 80%. Yes. Yeah. By looking at this one, you can directly tell the accuracy of the model. By the way, we also have the method to find the accuracy. I will show you that also. Okay. So now, how can you do the model evaluation using the confusion matrix in case of logistic regression? So a confusion matrix is a table that is used to evaluate the performance of classification model. Okay. You can also visualize the performance of an algorithm. The fundamental of confusion matrix is the number of correct and incorrect predictions are sum up class-wise. So for that, you need to write this line of code. From sklearn, import the matrix, and then matrix dot confusion underscore matrix y underscore test comma y underscore predict. The actual values of y versus predicted values of y, and then print the result of this one. You are assigning to the confusion matrix cnf underscore matrix, and then you can print it. So see here, let me run this code in front of you. From sklearn, import the matrix, and then matrix dot confusion underscore matrix. Use this method. This is our actual data for testing of y. This is our predicted values of the y. The result of this one you are assigning to this variable, and then you are printing it. Let me run this code in front of you. So it's become 29. See here. So it's look like an array. Yes, so array 4114. What is this? So let me explain you this one. So see, in the case of binary classification, the confusion matrix shows the number as follows. So in case of binary classification, so it's a binary classification. Am I right? Because the outcome here is the 1 or 0. 1 means the student get the admission. 0 means the student got rejected. So in case of binary classification, the confusion matrix produce the matrix that shows the number as follows. So see here, true negative in the upper left position. True negative which is present in the upper left position, which means we predicted no and they don't get the admission. Okay, so how many values are there? See here, true negative which is on the upper left position. This is one, true negative. So this means we predicted no and actually they don't got the admission. So see here also we predicted no and they also don't get the admission. So this 0, this one, the first one, and then 0 0 0 0, 3 values, and then this 0, 4 values. So this one is nothing but the true negative which is present on the upper left corner of the array, yeah, of the matrix, upper left corner. So what is meaning of this one? True negative in the upper left position in which we predicted no and they don't get the admission actually also. And then false negative in the lower left position, we predicted no but they actually got the admission. False negative in the lower left position. So see, lower left position, this is false negative. What we predicted? We predicted no but they actually get the admission. That is our false negative. So see here, we predicted no but they actually got the admission. So for this one, see here, we predicted 0 for this one but he got the admission. So that is our false negative. Only one value is there. Okay, which is present, false negative is present on the lower left position. False negative in the lower left position. So we predicted no but they actually got the admission. And then false positive which is present in the upper right position. False positive, upper right position, this one. So in which we predicted yes but they don't get the admission. We predicted yes but they don't get the admission. So see here, for him, C 0 1 1 0, we predicted false positive in the upper right position in which we predicted yes but they don't get the admission. We predicted yes but they don't get the admission. Yeah, this one, fourth one. Here we are predicting 1 but the fourth value here is 0. So this one. So here false positive which is present on the upper right corner in which we predicted yes but they don't got the admission. So this value, we predicted the fourth value is 1 but the actual value is 0. That is our false positive which is present on the upper right position. And then lower right position, true positive in the lower right position. These are the cases in which we predicted and they get the admission, in which we predicted that they will get the admission. Okay, we predicted yes and they get the admission. That is true positive. What is true positive? True positive is present in the lower right position. It is present on the lower right position in which we predicted yes and they actually got the admission. So see, that is 1 values. So we predicted 1 1, this one. So see, actually this one 1 1. Okay, and which one? This one. 0, 0, 1, 0, 0. Yeah, this one. Okay, that is our true positive. Got it? So by looking at this confusion matrix, you can say that out of 10, 4 and 4. Out of 10, 4 plus 4, 8 values are predicted correct, whereas 2 values are incorrect. So you can clearly say that the accuracy of the model is 80%. Got it? So I hope you understand this one. How this confusion matrix displaying the outcome. That is true negative, false positive, and true positive. Now let's see. Here you can see that confusion matrix which is in the form of the array object. The dimension of this matrix is 2 by 2 because this model is a binary classification. You have two classes 0 and 1. Diagonal values represent the accurate prediction. Okay, the diagonal values represent the exact prediction or the accurate prediction, while non-diagonal elements are inaccurate prediction. So in the output, 4 and 4 are the actual prediction and 1 and 1 are the incorrect prediction. This means out of 10, we got 8 correct prediction and 2 incorrect prediction. Got it? So these diagonal values are nothing but the correct predictions. So 4 plus 4, 8. Whereas this one, non-diagonal elements are incorrect prediction. So out of 10, we got 8 correct prediction, whereas 2 incorrect prediction. Got it? Yeah. So with the help of confusion matrix, you can easily do model evaluation of logistic regression. Okay. Now the seventh step is visualizing the confusion matrix using the heat map. So if you want to visualize the confusion matrix with the help of heat map, you can also do that. So let's visualize the result of the model in a form of the confusion matrix using the matplotlib and Seaborn. So let me explain you this code here. So see here. Import Seaborn as SN. Okay, it's optional. If you want to display the plot exactly below the cell, so you can write it. Okay, after that, Seaborn.heatmap pd.dataframe confusion underscore matrix cnf underscore matrix. So currently cnf underscore matrix is in the form of array, two-dimensional array. So I am converting it into the data frame with the help of pd.dataframe confusion underscore matrix, and then cborn.heatmap. So I'm creating the heat map for it, and then I'm adding the title, plt.title, y label, x label. Let me run this code in front of you. Okay, yeah, let me run this code first of all. Yeah, it's running. Just wait, and then I will run this code. Okay, so see, it's run successfully. 31. It will become 32. Yes, can you see this one? So this is the heat map. Yeah, visualizing the confusion matrix using the heat map. Can you see this one? Confusion matrix, predicted label, actual label. Yes. Now the question again comes to your mind. How can you measure the accuracy of the model with the help of coding? So again, I will want to show you that. Let's evaluate the model using the evaluation matrix, using the model evaluation matrix such as accuracy. What is the accuracy? It is nothing but overall, how often is the classifier correct? So using the matrix dot accuracy underscore score y test comma predict, you can find the accuracy like this one. Again, even though you can have already find the accuracy of the model using the confusion matrix, but also with the help of matrix dot accuracy underscore score, and then the y underscore test comma y underscore predict. This means that this is the actual test, actual values of the y. These are the predicted values of the y. The result of this one, yeah, matrix dot accuracy underscore score y underscore test comma y underscore predict. So I'm printing it. Let me run this code in front of you. So can you see that accuracy 0.8? This means 80%. And even by looking at this confusion matrix, the result of this one, you can also say that 4 plus 4. Diagonal values present correct prediction. Non-diagonal values represent incorrect prediction. So out of 10, 8 values are correct. This means 80%. Yeah. Okay, so this means our model is 80% correct. Yes. Am I right? This means out of 10, we got 8 correct prediction and 2 incorrect prediction. And even though if you want to find exactly the accuracy of the model, so you can find it with the help of matrix dot accuracy underscore score y underscore test comma y underscore predict, like this one. So you can see that accuracy of the model is 0.8, that is 80%. Okay. And finally, we consider 80% accuracy is a good accuracy. Okay. So accuracy, well, you got the classification rate of 80%, which is considered as a good accuracy. So you can see this one, classification rate is accuracy of 0.8, which is considered at a good accuracy. Okay. So now we will predict it. Now let's predict the values. Let's predict the outcome. What is our goal? First of all, our goal is to predict whether the student would get the admission into the prestigious university based on the GMAT score, based on the GPA, and based on the work experience. So let's do it. So what is your model name? What is your logistic regression classifier object? The name of this one is this one, logistic underscore regression. So in order to predict the values, you need to use the predict method, and then inside a parenthesis, inside a double square, pass the values of independent. So X is my independent variable that contain GMAT score, GPA, and work experience. So pass the GMAT score, GPA, and work experience. So let's predict whether the candidate with the GMAT score of 690, GPA of 3.8, and the work experience of 3 years will get the admission into the prestigious university or not. So call the logistic regression classifier object dot predict method. Okay, inside the parenthesis, inside the double square, write like this one. And the result of this one you will assign to the variable, and then you can print it. So let me run this code in front of you. Let me run this. Can you see this one? 0. So this means the student with the GMAT score of 690 with the GP of 3.5 with the 3 years of experience, he would not get the admission into the prestigious university. But if I make it 5, if the student has 690 GMAT score, 3.5 GPA with the 5 years of experience, let's see whether this student will get the admission or not. Let me run this code in front of you. Now can you see this one? It will become 1. So this means the same candidate with the GMAT score of 690 with the GPA of 3.5, but if he has 5 years of experience, then he will get the admission into the university. Got it? Are you getting it? Yeah. Now let's suppose, let's see this one. Let me run this code. Even if the student has a 690 marks in GMAT with 3.8 GPA with 4 years of experience, he will get the admission. If I make it 2, let's see what is going to happen. Can you see this one? It becomes 0. But if the candidate has only 2 years of experience, he will not get the admission. Got it? Let's see if he has 3.9 GPA. Let's see what is going to happen. Again, he will not get the admission. If he has 695 marks, let's see what is going to happen. Again, he will not get the admission. Okay. Let's suppose if he has 699 marks, again, he will not get the admission. So let me make it 3 years. Can you see this one? He got the admission. Okay. Got it? Yes. Yeah. So now finally we have built a logistic regression model that will predict whether the candidate would get admission into the prestigious university based on his GMAT score, GPA, and work experience. Got it? Now you can tell me any GMAT score, GPA score, and the work experience, and we can find whether the student will get the admission or not. So tell me anything. For example, if the student has 600 GMAT marks with 3.8 GPA with 7 years of experience. Let's see whether he will get the admission or not. Can you see that? He will get the admission. If I make it 5 years, let's see. No, he will not get the admission because his GMAT score is a little bit low. But if he has 6 years of experience, he will get the admission. Got it? So finally, we have built the logistic regression model that will predict whether the student will get the admission into the prestigious university based on the GMAT score, based on the GPA, based on the experience. Got it? And finally, we have solved a real world problem with the help of logistic regression. Got it? So I hope you enjoy it. So it's very easy. Import the necessary modules, read a data from the CSV file. So this is our CSV file that has GMAT, GPA, and work experience, and the admitted 4 columns. So based on these 3 columns, we need to predict this one. So put the data of these 3 columns and assign it. I access the data under these 3 columns and assign it to the X like this one. Okay, that is our independent variable X, and the dependent variable is Y. So once we're done with that, after that we need to divide, or we need to block our data into training set and test sets with the help of train underscore test underscore split. So x comma y comma test size, test underscore size 0.25. This means we have broken down our data into the ratio of 25% into the ratio of 75 to 25. So 75% of the data you will use for training the data, training the model. Okay, and remaining 25% of the data you will use for testing the model. Okay, the result of this one, it is going to return x underscore train, y underscore x underscore test, y underscore train, y underscore test. So this is our x underscore test, the 10 values, that is 25%. And then after that, once we split the data into training set and test set, we need to create a logistic regression classifier object, okay, with the help of this one. And then once we have the logistic regression classifier object, you need to fit the model. So this is our logistic regression classifier object dot fit. We need to fit the model on training data. So x underscore train comma y underscore train. So fit the model with the data. And once we have done with that, we can use the method predict to predict the outcome. So to predict the values for test data. So logistic regression, that is our logistic regression classifier object dot predict x underscore test. The result of this one you should assign to the y underscore predict, and then you can see the predicted values of the y. So these are the predicted values of the y, whereas y underscore test, these are the actual values of y. So you can compare this one with this one. Okay, and then we have seen the model evaluation using the confusion matrix. So how to create the confusion matrix, where the diagonal elements represent the correct prediction, non-diagonal elements represent the incorrect prediction. And then we have seen how can you do the data visualization of confusion matrix using the heat map. Yeah, visualizing the confusion matrix using the heat map. And even though if you want to find the accuracy of the model, so you can use matrix dot accuracy underscore score y underscore test comma y underscore predict. So you will get the accuracy. So accuracy 0.85, this means 80%, which is considered as a good accuracy. So finally you have a regression model, logistic regression model, yeah, that is going to predict whether the student would get the admission or not based on the GMAT score, based on the GPA and the experience. And finally, using the logistic regression classifier object dot predict method, okay, inside that, inside a square bracket, inside another square bracket, we have passed three values because x is containing the three values. X is our independent variable that contain three values: GMAT score, GPA, and work experience. So we pass the GMAT score, GPA, and work experience. So if the candidate has 600 GMAT score with 3.8 GPA with 6 years of experience, he will get the admission. Let me run this code again. Yeah, he will get the admission. But if the candidate had 600 marks of GPA, 3.8, sorry, 600 mark of GMAT score, 3.8 GPA with 5 years of experience, he will not get the admission. Can you see this one? Got it? So I hope you have understand it. Yeah. So now I hope you understand what is classification. Okay, the algorithms under the classification and logistic regressions. The first algorithm comes under the logistic regression, under the classification is logistic regression. So again, make a note. Logistic regression is a classification. It is not the regression. Okay. So I will continue with the next algorithms that comes under the classification, that is decision tree. Okay, so now I hope you understand the logistic regression. That is very important algorithms under the classification. So I will continue with the next point of decision tree classification algorithm in the next session. Okay, yeah.